Hello, this is Domenico with Easynomics, and today we're going to look at another real-world example of substitutes as a non-price determinant of demand. We're going to be looking at cigarette packs or prices for packs of cigarettes in the state of New York and in neighboring states, and how that can lead to consumers in the state of New York looking for cheaper alternatives out of state lines, beyond state lines. This is part two of a little video series where we're breaking down taxes. In the previous video that will be linked in the video notes below, we really broke down how a per unit tax works, leading to a shift in the supply curve and highlighting how the firm is always operating along their S1 curve, which includes the cost of the employment of land, labor, and capital resources. They produce the final output, in this case, a pack of cigarettes, and then there's one additional cost of production, which is the added tax at S2. We then reiterated a more simplified tax model, which you'll be using for your IB paper exams, and we graphed and analyzed it. So using this example, again, we're going to be using the idea of non-price determinants, consumers looking for a cheaper alternative, and perhaps also looking for a cheaper alternative in parallel markets. In that video, we looked at and used the state of New York, which has the highest price for a pack of cigarettes, being about $12 a pack, which includes a $5, approximately just over a $5 state tax on each pack. But if we look at the neighboring states like Pennsylvania, New Jersey, Massachusetts, Vermont, they offer packs of cigarettes at lower prices. And that can incentivize consumers or even organized crime to purchase cigarette packs outside the state of New York and then bring them back into the state to sell them in parallel markets. Not too far away, we also have the state of New Hampshire, which has a significantly lower state tax. So again, according to this study in 2024, the state of New York had the highest price per pack, about $12. And in this study, showed that New Hampshire had a combined price for a pack of cigarettes being $7.73. So if we round it up to 8 versus 12, that's a $4 difference. But the state of New York increased the state tax by an additional dollar, bringing that price up to 13. So here's an article highlighting, and again, it could be a good idea for an internal assessment, that in 2023, the state of New York raised the state tax on cigarette packs by an additional dollar, taking up to $5.35 a pack from the previous $4.35. Okay, so that will be our applied example. So let's go ahead and graph and analyze a non-price determinant being and using substitutes as an example. So let's just take a couple notes here. Let's just review. All right, so just a little bit of review. Non-price determinants of demand. What is a force, a variable, other than price being held constant, that can cause the demand curve to shift outward or shift inward? You should know that there's various variables. One includes a change in income, and I'm going to put the delta sign for change. A change in income will lead to a change in the demand for the good or service. And there's other videos that goes into detail about that, the angle curve and so on. Number two, a change in tastes and preferences. So the price is being held constant, but consumers are increasing their preference or taste for a particular product. Maybe it's more popular. Maybe there's a celebrity or influencer that's popularizing their products, so demand increases, or maybe it becomes unpopular and demand decreases. Number three, future price expectations, or maybe change in people's thoughts about future price expectations. If you expect the price of a product to increase in the future, then you're going to buy that product now in the short run. Or if you think that price is going to fall in the long run, then you're going to wait and not purchase, and the demand will decrease. And you'll wait until the long run where the price does fall, and then you'll increase your demand. Number 4, price of related goods, or changes in price of related goods. And that includes substitutes and complements. And I'll provide a link to playlists that covers these topics and provides extensive examples on those. And next is a change in the number of consumers. In the number of consumers. This might play into demographic changes within the population. So this video is going to focus on substitutes. Right, we're going to use that example of New York State. All right, we're going to focus on substitutes, looking for the cheaper alternative. This is a good review. You should know this. This could be asked of you as a short answer question, maybe on a paper 2 or paper 3. State 2 non-price determinants of demand. And so here you have 5. Okay. So let's go ahead and illustrate substitutes in the context of the price of cigarettes per pack in the state of New York versus New Hampshire. New York State, okay? So we're going to draw an inelastic demand curve due to the addictive quality of cigarettes. PED, as a side note, for addictive products would be less than 1, meaning that the percent change in price would be greater than the percent change in quantity of demand. And that enables governments, state governments, national governments to really increase the price or the tax on an inelastic good significantly, where it will not have too much of an impact on the producer, but it will have a significant impact on the consumer. It's very regressive. These types of taxes, I have another video that goes into those details, but we're just refreshing our memory that PED for inelastic goods less than 1, where the percent change, the change on the y-axis being greater than the change in the quantity. Then we'll draw another demand curve. For New Hampshire, again, very inelastic demand curve because cigarettes are addictive. I'll label this D2, and we want to remember that the demand curve is equal to the marginal benefit. What's the benefit gain from consuming an additional unit? Okay. All right, so a simple way to draw non-price determinants, and that'll be the focus, non-price determinants of demand. And we're going to focus specifically on substitutes. Okay. So we're going to start off with a particular price for cigarettes. And let's say this will be a simple way to illustrate the substitute model causing a change. We'll label this P1 and Q1. This is point A. And then we'll have a price set over here. I'll label this P3, and you'll see why in a second. And this will be Q3, and I'll label this point C, and you'll see why. So the state of New York has very high state tax. So that's going to raise the price of cigarettes in the state of New York significantly. So let's take that up. Maybe we'll use a different color just to emphasize this change. Let's take it up to this point. Okay. So here we have a price at P2, and that's going to reduce the quantity of demand from Q1 to Q2. Okay, and that's a movement along the demand curve from point A to point B. according to the law of demand. There's a negative causal relationship between price and quantity of demand. So we can just emphasize that by showing that there's a movement along the demand curve from point A to B. All right, price increases, quantity of demand decreases from Q1 to Q2. And we notice again the change in price greater than the change in quantity. In that example, the state of New York, the price of a pack of cigarettes on average is sitting at about $13 a pack. All right. Whereas in the state of New Hampshire, let's say that they maintain their state tax at about $1.78, and on average, the price of a cigarette is sitting at $8. Okay, so that's a significant difference between the price of a pack of cigarettes in New Hampshire being $8 versus a price for cigarettes being $13 in the state of New York. That's a $5 difference. So that can create the incentive for New Yorkers in their reduction in the quantity of demand for cigarettes being sold legally in the state of New York. That decrease can mean that these consumers, that distance between Q1 and Q2, they're switching away and they're looking for a cheaper alternative. And that could be in the state of New Hampshire, or buying packs of cigarettes that have been imported into the state of New York by organized crime. So that's going to lead to an increase in the quantity of demand and the demand curve, with price being held constant in New Hampshire. So we can illustrate that with the demand curve shifting out from D2 to D3 equals marginal benefit 3. Again, we're going to hold price constant. New Hampshire is not changing the price of their cigarettes. It's remaining at $8. And we notice that they're getting an increase in the quantity of demand because they are the cheaper alternative. So there we have that shift in the demand curve as a result of an increase in price. So that's what we would expect with consumers finding a cheaper alternative. That here we have an increase in price leading to an increase in the demand for the other good. So an increase in price of good A, cigarettes in the state of New York, leading to an increase in the demand, the overall demand for good B, or packs of cigarettes in New York. So there's a positive relationship between these two goods, and vice versa. If the price was to fall and New York became the cheaper alternative, we would expect consumers from New Hampshire to switch over to buying cigarettes in the state of New York, crossing state lines and buying that. Okay. So I can analyze this, and then we can just highlight a few other things, and then we'll be done with this video. So on graph A, we have the market for packs of cigarettes in New York State. Graph B is the market for packs of cigarettes in New Hampshire. We're looking at the market demand. In graph A, it's downward sloping according to the law of demand, labeled D1 equal to marginal benefit. And in graph B, we have two downward sloping demand curves labeled D2 and D3 equal to the marginal benefit. These are the market demand curves for packs of cigarettes in these two states. Y-axis we're measuring price, x-axis we're measuring quantity. We also notice that the PED value for these two goods, or these packs of cigarettes, is less than 1, meaning it's very inelastic, meaning that it has an addictive quality where even if price was to increase, quantity demand doesn't fall significantly because people are addicted, they continue to consume. So in the state of New York, we start off with a price of P1 with a quantity demanded at Q1 at point A. And in graph B, in the state of New Hampshire, we have a price set at P3 with a quantity demanded at Q3 at point C. As a result of the state of New York increasing the price of cigarettes through increasing the state tax, driving price up from P1 to P2. Again, we notice that the change in price is greater than the change in quantity. That leads to a reduction in the quantity demanded from Q1 to Q2, a movement along the demand curve from point A to point B. And those consumers in the state of New York that reduce their quantity demand for cigarettes, they switch over and look for a cheaper alternative, and they find that alternative in the state of New Hampshire. So although the state of New Hampshire maintains a price for a pack of cigarettes averaging out to $8, there's an increase in demand from those consumers in New York switching over to looking for the cheaper alternative that causes demand to shift out from D2 to D3, which is the increase in quantity demand from Q3 to Q4 for point C to D. What that means in terms of total revenue, if we want to get into that, is that total revenue for firms offering packs of cigarettes in the state of New Hampshire, both legally and in the parallel markets, increases. So originally we had total revenue being P3 times Q3, or area A. But then it extends to P3 times Q4, or areas A plus B, which I'll label here. So even though New York State's raising that price, they're actually increasing the revenue being generated by firms selling packs of cigarettes in the state of New York, both legally and illegally. Okay? All right, so I can just make a note about that. Total revenue initially was equal to P3 times Q3, which is equal to area A, and that changes to total revenue 2, which is equals to P3 times Q4, equal to areas A plus B. So we can see that total revenue 2 is greater than total revenue 1. Okay. So that's one way to do it. Last, maybe if you're working on this for an internal assessment, you can go ahead and incorporate the supply curve on your graph A. So you can have a relatively elastic supply curve, assuming the cigarettes are a manufactured good with spare capacity, ability to store stock. So I can label it S1. That includes the tax. All right, and that'd be S1 plus initial tax. Maybe I can put the initial tax as there is a tax there. And that initial tax was $4.35 per pack. And then I can draw the supply curve shifting upward again by the additional dollar added to S2 S2 plus the increase in tax. So tax 1, tax 2. All right, and that's the force causing the price to go up. Okay, so that's it. In the third video, we're going to do a paper 3 practice using the same real world example of cigarettes in the state of New York, calculating changes to consumer and producer surplus and tax revenue collected by the government. If you have any questions, feel free to comment those questions below, and don't forget to subscribe and to like. Thank you so much.